All right. So the kind of the algorithm here for this is the first thing you want to find is the distance between these 2 points.
Mhm.
And in math, distance is typically right minus left.
All
So
right.
you got to be able to quickly do that. And common denominator, right? You get, what is that? 3/12, 4/12, 1/3. Okay, so you have to first get the distance. Is that okay?
Yep.
That doesn't seem right. I'm really bothered by this. Why is that not right? So 3/12. Yeah, it is 4/12, 1/3. Okay. The next thing is you got to figure out what is. So that's first. The second is you're going. What is 1/2 of that distance? So half of that distance of means multiply. 1/2 of 1/3 is 1/6.
Okay. Good. That's
Third
what I
part of the
got down.
algorithm is you have to take your starting point and adding the result from the previous part. So plus the I don't know, the increment, we'll say. So you take wherever you started, which is 1/4, and you add the 1/6 to it.
Okay.
Is that kind of what you did?
Yeah, I was missing that last step there, but there we go. Got it. All right, very well. That makes sense.
Number 7.
Yeah, yeah.
All right, find the number that's 2/5 the way from 1 1/5 to 2 5/6. So I'm going to first convert these to improper fractions. And then that's 17/6. And we want to find the distance between them. All right, you want to do that for us? Let me know what you come up with.
Okay. Uh, 43/30.
Yeah, that was actually really fast. That's good. 43/30. So you find the distance, okay? And you now want 2/5 of that distance. Sometimes, and you want to try and pre-reduce here. So like 2 and 2 goes into 30, so that's 15. That'll save you just a tiny bit of time here. Of course, none of these numbers work out. 43/75.
Mhm.
43 is prime. Nothing you can do with that one. Then you have to take your starting point, 7/5, and add to it this little bit.
Yep. Calculate that.
Uh,
All right. 17/6.
does not work out that nicely. So did your common denominator is 75. So you're multiplying by 15.
Oh, whoops, sorry. Whoops, I wrote it down wrong. Give me a second.
That's okay. These are not great. They're very
Yeah.
numbery. They're not.
148/75.
Yes.
What a convenient number.
Yeah. So let's just take a step back, and I'll I don't know anything about flying airplanes, but I'll just presume there's some. It's like you are here, and there's a target A and a target B, and there's something somewhere in between them. We'll call it C, and C is, pick your fraction. It's 2/5 between A and B,
Mhm.
and you want to know where that is relative to here. Now in the math world, here is 0, right?
Mhm.
but it's not always 0 in the real world, right? It could be, it's all relative. But that's why you add in that, like, that's the adding in part.
Yeah. Yeah, this is the
Plus,
kind of quick math that pilots would do.
yes. I don't know why you would do this exactly, but that, I mean, I don't know the context of this, but it seems like a reasonable thing to do.
Oh yeah, no, that's believable. Say I was hanging between Apache Peak uh and Tombstone and then eventually Bisbee. You know, I would
Okay.
probably do something similar to that. That's where I was last playing. So
And all of this assumes a straight line. And I don't know if that's
Mhm.
true
Yeah, yeah, it
or
definitely
not.
does vary most of the time playing, but you know, it could be hypothetically.
I mean, you get closer and closer, it's probably more of a straight line, I
Mhm.
guess. But
Yep.
okay. That is the lesson. I mean, that is like, there's no rabbit holes to go down. I mean, the way to make these harder is to use variables, so you don't really have numbers or the fractions like we saw, or, you know, horrible percentages like what's 37.5% of the way between A and B.
Mhm.
Uh, but the algorithm's always the same. Find the distance, figure out multiply the distance by this, whatever your multiplier is, and then add it to the base.
All right. You're well.
Would you like us to, I mean, if you got some more from, say, like the next unit that you want us to do, that's always a good
Mhm. Well,
thing, or we can keep going through whatever you want on this assignment.
yeah, yeah, probably since this is, you know, doing a couple hours. Let's see.
This emergency.
Indeed, exactly. Yeah, today's been very busy. Um, all right, so problem number 8. I just want to make sure that, you know, I got the concept. So and then we'd move on to other things. Also, um, would we still be meeting over the summer? I think mom wants me to take some kind of math class during the summer, but I'm not really sure what it is yet.
Yeah, so the reality is most students don't do math in the summer,
Mhm.
right? So I am available. I make time for my customers.
Yeah, yeah.
It does not have to be 7 o'clock on Wednesday. In fact, I don't want it to be 7 o'clock on Wednesday because I switch my schedule up in the summer, but I will make time. If you're going to take math,
Yeah.
I will be available for you. And
Sounds good.
and she's always just, if you want to let her know, dad know, like I'm happy to have dialogue anytime. I mean, you're closer to being an adult than not. So, you know, it's just you and I, but if there's something, they can always contact me and
Mhm.
we'll figure it out. But yes,
Yeah, yeah.
you mentioned consumer math. Is that what you're thinking?
Yeah, that's gonna be next year. I think though, during the summer, I'm going to be taking some other more advanced math class. I don't really remember, but yeah, I'm going to be graduating next year, like as in, you know, 1.5 years of school
Cool.
basically from now. And so yeah, definitely want to get some stuff done during the summer.
Sure. Yeah. I mean, it makes more sense rather than just, you know, what the average, what are you, 16, 17 right now?
I'm 16.
Yeah. The average 16-year-old's on their phone. They're not doing school.
Yeah,
So
yeah,
it's
exactly.
great. It's great use of your time. You'll be way ahead, miles ahead of your peers if you keep doing this kind of stuff.
Yeah, indeed.
All right. So substitution. So your book tends to say like, here's a problem that we would normally do one way, and let's use the other way. That's much harder.
Mhm.
Substitution means you need to solve for one variable in one equation. It's not really great. Like you'd be looking for an equation where there's a 1 in front of a variable or a -1. This has neither,
Mhm.
unfortunately. So what I'm going to do here is just arbitrarily choose the top. It looks slightly easier and solve it for y.
Okay.
So subtract 3x from both sides. I prefer to put it in front of the number, divide by 2. So it's -3/2 x plus 5/2. That is going to go in for y in the second equation.
Mhm.
5x plus 6 times. And actually, I regret doing the notation I use, but this is okay. This will work out. equals 7. And whenever you're multiplying in, it's better to divide before you multiply. So I know typically it's like 6 times -3 is -18, but if you divide first, the numbers get smaller. Division for multiplication, then you multiply. So it becomes -9x. 6 divided by 2 is 18. I'm sorry, 3. 3 times 5 is 15. And you might, with smaller numbers, you can get away with it. But the larger they get, the better this method is.
Yeah.
Combine like terms. Move the 15 over. Divide by -4. X appears to be 2.
Right. And then we'd substitute that in the original equation.
I probably would not go back to this one. I'd probably go to the 3x plus 2y equals 5, and should work in both. So we got 3 times 2 plus 2y equals 5. So we get 2y equals -1, y equals -1/2.
Okay.
So substitution means solve for one variable, put it in the other. This is actually not a typical substitution problem because it doesn't work out nicely where you've got one already solved for, but can't do anything about that.
Yeah. All right. Very well. Let's see. Okay. So question set 11. Question set 1. Problem 11 is what I'm trying to say.
What is the last word? Which of the following sets of ordered pairs are
functions?
Okay.
Yeah. My phone's camera is not the best, but I did just get a new a brand new high quality iPad for my flying, and so I'll be able to use that to scan and it'll look better.
Yeah, I'd recommend your looks like, are you using Genius Scan?
No,
Cam scanner?
I think it's called Scanner Pro.
Okay. The scanner that I use program, and there's a million of them out there. It like yours is just converting pictures. There's a way for you to know to just sort of grab the black text and not the rest of it. Like, yeah, I'll show you that in a minute. Okay, let's talk about functions though. So the way functions work is you have an input and an output. And,
oh, sorry. I was just saying I found what you were talking about in these settings. All right, auto text recognition. All right, hopefully that helps.
You don't want to convert it to, you don't need to convert it to that. Let me try and find one. Give me just 1 minute here to find something. No, I can't do that very quick. Okay. If we got time at the end, I'll do it. Let me know when we can get started back on this. But I use Genius Scan. You may find it's a little better. I do the free version. I don't pay for anything that I don't have to. There's an input.
What'd you say it was called?
Genius Scan.
Okay.
I think so. I think that's what it's called.
Well, if it's free and it works, then there we go. I see it. Okay. I'll go and get that. Oh wow, that's popular. Okay. Yeah. All right. I'll get that downloaded then.
Okay. Okay. So functions have inputs and outputs. So let's just say, and I'll use that first data point. 5 goes to 7. 7 goes to 5, and -3 goes to -2. So first thing you're looking for is, are there any duplicates? Like, do you see any duplicates in the input?
Negative.
No. So this is a function. So that's your first check. Duplicates in the input. That doesn't necessarily mean that it is not a function, but that's the first thing you look for. Okay, and what this is saying there really is that 5 always goes to 7. 5 always goes to 7. 5 always goes to 7. You don't have any question about what 5 goes to. So let's look at letter B here. So B is kind of the same way. You've got and sometimes they show it this way in a kind of in a circle. In a circle, 5 goes to 7, 4 goes to 7, and -3 goes to 7. Actually, so I shouldn't draw this. So 5 goes to 7, 4 goes to 7, minus 3 goes to 7. Again, are there any duplicates in the input?
No.
That's right. No big deal here. 5 goes to 7, 4 goes to 7, minus 3 goes to 7. Okay, so this is also a function. Let's look at the last one here. Minus 2 goes to 5, 4 goes to minus 2, and 4 goes to minus 2. So notice I didn't draw 4 again because it already goes to minus 2.
Mm-hmm.
So this is also a function. Again, there's no duplicates on the input. So you might be asking, well, what would it be if it were not a function? Like, what would it even look like?
Mm-hmm.
So let me show you that now. So let's say, where do you like to get food from? You have favorite food place?
Chipotle.
Chipotle. Okay. So think of your input is you want a chicken bowl. And you go there one day, and what does it normally cost? $10, maybe $9, somewhere in there.
Yeah.
And then I go in right after you, and they're like, yeah, we don't like you as much. It's gonna be 20.
Hmm.
Do you see the problem with this?
Mm-hmm.
So let's say you found another family. Like, is it gonna be 10 or is it gonna be 20 when you go in there?
For me, 10, but
Right. So this is not a function. And the reason it's not a function is because you don't know where the output is going. You don't know which one it's going to be.
mm-hmm.
So in terms of when I kept saying the duplicates, it'd be like saying, okay, Wyatt is there, but but M, which is the same input. I'm at Chipotle, I go there. And so it's the issue here is like, in terms of numbers, it'd be like 4 going to 3, and then 4 also going to minus 3.
Mm-hmm.
Which one does it go to? So that's why you're looking for duplicates. If you see something like 4, 3, and then 4 comma minus 3, because they go to different outputs, you have a problem.
Mm-hmm. So it wouldn't be a function then.
It would not be a function. But all the ones they gave you are functions because, first of all, the inputs were unique. Okay, 5 goes to 7, 7 goes to 5, minus 3 goes to minus 2. It's okay if they go to the same output because they're all unique. It's okay if there's a duplicate. I think in the third one we saw 4 minus 2 twice. That's okay because it goes to the same value. The issue is when the same input goes to 2 different outputs
Uh-huh.
or more.
Gotcha.
Because how can you do anything in life if the same input gives you a different output each time?
Yeah.
It'd be very
Kind
frustrating.
of sounds like life in general, you're raised
Life
in a
is not
good
a function.
home, and then some people, end up going to prison, then somebody else becomes an astronaut or the president of the USA.
Yeah, well, there's some great things out there. It's like there's like 2 guys that say my dad was an alcoholic, my dad was an alcoholic. One becomes an alcoholic and one becomes, the greatest person in the world because their dad was an alcoholic.
Yeah.
And so the point is like you can't. Yeah, I mean these things happen, right? But you have a chance. You have a chance to be
Exactly.
beyond these things.
Also, it almost looks like that stick figure for the alcoholic. It almost looks like he's throwing up. The
All right, there we go.
most mature math session ever.
Yes. Well, this is good. This is life stuff's important to talk about.
Exactly.
Okay, where do you want to go from here? What else
All right.
can we look at today?
Just want to get all the hard ones out of the way. You see any that you think I need help on?
Yeah, we should do the graphing one, number 18, I think. No,
Or
20,
19?
19. Yeah, we should do that.
19 or 20, they're both graphing.
We'll do 19 first.
Okay.
You've mentioned this one several times in the past as being
Sounds
a
good.
pain point here.
Mm-hmm.
All right. You got to kind of draw a line here of best fit. And, the varying degrees of success on this, it's like, what does that line look like? I'm going to try really hard. when I'm doing it, I'm trying to pick a line that kind of goes through the center of them, same up above, same below. But I'm also kind of trying to get where I got some nice points from which to choose to determine the slope. So I'm kind of trying to do two things when I do that. So ordered pair number 1 is 4, 200. Ordered pair number 2 is 6, 75.
All right.
Will you calculate the slope? You can either do that graphically or using the slope formula.
Yep. Let's use the snazzy new iPad to calculate. Let's see.
Does your iPad, is it got a pencil that works with it?
No, I didn't get one, but
You didn't
like
get that? Okay.
it would work with one.
If you do, I recommend Good Notes for that.
Okay.
It's a good, solid note-taking app most students use.
All right.
They got a free
Yeah.
version.
That would actually be very helpful with my flying as well. It's something that as a homeschooler, you don't really have the instinct to take notes because quite frankly, you just always have the books in front of you, and so you don't really need to. And so yeah, no, that would definitely be something that would help a lot.
But on the positive side, you recognize that you live in a world where you're not bound by, oh, I only have this textbook at my disposal to solve problems.
Yeah. This is true. All right, so calculating, I get a slope of negative 125 divided by 2.
Okay. Another recommendation here is the Desmos Scientific, which is the calculator. It's another app. It's free.
Yep, that's why I use all the time with my math.
Oh, cool.
It's so handy.
Okay. So the way we've done these in the past is I've recommended writing the more standard y equals mx plus b, y equals minus 62.5x plus b. And then to solve for b, you're going to use one of these ordered pairs. I'm slightly leaning towards this first one. So 200 in for y, minus 62.5. Okay, go ahead and solve that for b for us, please.
Okay. Okay, 450.
Good. So the we put that back in. So we would write y equals, leave it off the side here, minus 62.5x plus 450. But instead of using y and x, you go back to the original variables. Y is really s, x is really p. Salt equals minus 62.5 times p plus 450.
All right, very well. Okay.
We should do 20
Yep.
either next or at some point soon.
Yeah, we can do 20 next.
Okay. All right, resultant force. All right, so force 1 is this red one kind of going to the right. It's going completely to the right. So the force 1 is 12 in the x direction. How do I want to do this? Y is a little bit more complicated. It's got both an x and a y component. You want to draw these things in such a way where you get a triangle like that. And if you need to, you can even come off to the side and draw it again, just to kind of simplify all the stuff that's going on. So you need the one to the right and the one down. The reason it's to the right is because you get what the resultant vector is always going. You have to get there from the x and the y. So if you go left and down, you don't get there. If you go down and right, you get there, but you always go left and right first. So the reason I bring that up here is we've got to find the x component, y component using sine, cosine, and tangent. I'm sorry, sine and cosine. X sorry, let's start with cosine of 64 is x divided by 10. So the x is 10 cosine 64.
Mhm.
So that goes up here. The reason it's positive is because it's still going to the right. The y is similarly like sine 64 y over 10. Y is 10 sine 64. Now this one is going down. The triangle doesn't tell you that. You have to infer that on your own. You have to say, okay, it's minus 10 sine 64 degrees.
Mhm.
So you want to get these two intermediate results, and then the resultant vector is the square root of x squared plus y squared, and then the angle is the arctangent of y over x. So if you're using that Desmos, make sure you're in degrees like that. I'll calculate these and we can compare notes here in a moment.
Okay. I still haven't got a case for it, and so I have this really weird kind of, now it is coming in the mail, but I have this really weird kind of setup where I don't know, it's not that sturdy, but hopefully once that comes in, I'll be able to set everything up quite nicely.
Yeah, no, you gotta, it's like gotta get the right piece. You know, it's,
Yep. Who knows? Maybe I'll drop it out of my plane or something while I'm flying.
well,
Okay.
I mean, you spend all this money to buy something. We got to take, well,
Yeah, exactly.
take the $10, $30 case to protect it. It's
Yeah, exactly.
like-
Exactly. All right.
let me know when you've got some numbers or want to.
Okay. Um, okay. Oh wait, hold on. -45.
Or what? What are you giving me?
Oh, for the uh tangent.
I
Yeah.
got something. I got something a little different here. Let's go back. What did you get for X? If you have that,
Let's see.
it's possible I made a mistake. That's why I'm asking for us to go.
Oh,
through it.
okay. I think, hold on. All right. -75 degrees. I forgot the 12.
12 plus 10 cosine 64. Give that another try here. Make sure you're in
Okay.
degrees.
12 plus.
Oh, you know what? There's my mistake.
Okay. That's gonna
It's
be 16.38 for X. And for the tangent, I got
yes,
-75.
yes. 16.38. What about for Y?
Okay. -8.99.
Okay. All right. And then did you get your resultant? Because that's more important than the angle. You have to give the resultant first.
So that'll be okay. Let me just calculate that. Okay, 18.68.
Yes, 6.9. And then the angle, one more time.
Okay. Angle is -75.
See, we're way off on that. You're using tan inverse y over x.
Yeah. Here, let me do it again just to make sure.
Yeah, don't mind.
I think I flipped the two. Whoops. Let's see. Okay, yeah, I think that's what I did. I got
There it
-28.76.
is. Yeah.
Okay,
Okay, great. You got it.
all right. I did x over y by accident.
All right. So the if you're asking me, let's see, we usually do a systems, which this does not seem to have. So and we've done we've done a few like 14, but I mean maybe 27 completing the square.
Okay.
You tell me.
Yeah, sure. Yeah, we can go and do 27.
Excuse me.
And then actually, well, we can do 27, then 14, I suppose.
Your choice. What do you want to do first?
14, I guess, since that would be roughly in order, I guess.
Okay. All right, we got an exponent here, 2a to an exponent 1/3. So whenever you have an exponent to an exponent, you multiply them. You remember that from last week or week before?
Yeah.
Okay, so you're going to multiply 2a times 1/3. That becomes 2/3 a. So that's the numerator. X is 2a times 1/3, 2/3 a.
All
That
right.
takes care of that piece. Then we can bring the other stuff down. Okay, I would recommend working on the numerator first. So when the bases are the same and you're multiplying, you add the exponents. So you can think of this as 2a over 1. Any idea? Can you give me the new numerator, please? Correct exponent.
Okay. X equals 8/3a.
Good. And then way you could rewrite this denominator, which I think would be helpful, is write as 1/2 a. And then when the bases are the same and you're dividing, you subtract the exponents. So you got to take 8/3 and subtract 1/2 a like that.
Yep.
So what is your final answer on that?
Let's see. All right. 13/6. So that'll be x with the exponent of 13/6 times a.
Isn't it? Yeah, 13/6. So that's right. And you can just leave it
Okay.
like that. You don't have to make it a mixed number.
All right. Sounds good. Okay.
27.
Yes.
All right, solve by completing the square. Wow. Okay. So first thing is to move the constant to the other side of the equation. And we're going to try and fill in this position here. First, though, is you factor out the -5 from everything. So it becomes x squared plus 1/5 x plus unknown equals. So this red box and red box are the same, but this thing in here is different. It's unrelated to that. But any questions on factoring out that -5? You multiply in, you should get back to the previous line.
No, I don't think so.
Okay, so the algorithm says you divide by 2 here. So it's x plus 1/10.
Squared.
Is that okay?
Mm-hmm.
Okay. Then to go back, you have to square this term here.
All right.
So that's 1 over 100. To get the number in the red box here, you have to multiply in that last one. So that ends up being minus 1 over 20. Minus 1 over 20. This is the rare exception where it is negative. And it has to do with the fact that this GCF is negative. That's why it's negative. If GCF is positive, or sorry, not the GCF, the leading coefficient. Leading coefficient is negative. This is negative. If it's positive, it's positive. On the right, you're subtracting. So that's think of 5 over 1, 100 over 20 minus 1 over 20 becomes 99 over 20.
Mm-hmm.
Please let me know if I need to clarify anything.
All right. Sounds good.
This is okay so far?
Yes.
All right. So, it's not great. I mean, it's hard. This numbers aren't working out nicely, but we're on the right path here. We have to divide by -5 or multiply by -1/5, the reciprocal. This ends up being minus 99 over 100 equals x plus 1 over 10 squared. Whenever you see a negative on the right-hand side and you're taking a square root, that indicates that the solution is not in the real domain. You're going to have two imaginary solutions or complex solutions. Do you remember that from the other lesson?
Yeah. Yeah.
Okay, so you take a square root of both sides, x plus 1 over 10 equals plus or minus square root of negative 99 over 100. So it's plus or minus square root of negative 99 over square root of 100. The top is plus or minus I square root of 99. The
Mhm.
square root of 99 does reduce. 3 and 33, 3 and 11, pair of threes. The bottom becomes 10. So this is plus or minus I 3 square root 11 over 10. X plus 1 over 10 here.
All right. And
Now
that'll be
you subtract. Now it's just 1.6. I think you'll appreciate this. The bottoms always share the same denominator. Like this always works out in these problems. It's kind of neat when you've done a million of them and you
Mhm.
you start seeing that. Sometimes they put the I kind of more next to the root. This is your final answer here on that.
All right. Very well. What do you think would be a good question to go to next?
What is the meaning of life?
Hmm.
No, I don't know. We've looked at a lot of them here. I know there's
Mhm.
there's some we've never touched. Like we've never really talked much about eyes, the like 17 and 18. That's fine. We've never really worked on, I don't know, rationalizing like 21 and 22. I think we did a unit multiplier recently, but I think that's, you can do that on your own.
All right.
I don't know. You tell me, what kind of stands out to you? Oh,
Well,
10. I can't see 10, but 10 looks like a nonlinear system.
yes.
That might be worth doing here.
All right.
If you're
Sounds
asking,
good.
you'll have to read it to me though.
Okay. All right. X squared plus y squared equals 16.
Good.
2x squared minus y squared equals -4.
-4, you said, right? So does this look right on your paper
Uh,
or on your
yes.
screen? Sorry. Okay. Normally, you always use substitution, but because the y squareds are opposite in sign, you can use elimination.
Okay.
So the way this works is you add them up just like you do other systems. 3x squared equals 12. Divide by 3. I wasn't expecting this one to work out so nicely. And so what are your solutions to this part? What does this become?
X equals 2.
Okay. And
And then we put that into the original
nope,
equation. So,
there's two solutions. What's the other one?
oh, right. -2.
-2. Good. All right. And then this is where you have to find the other ones. Okay. So
Mhm.
the other ones are, be careful here that we actually are going to find them all. So we go to, let's go to the first equation. So it's 2 squared plus y squared equals 16. Y squared equals 12. So y equals plus or minus the square root of 12,
Mhm.
which reduces to 2 square root 3. So here's what that's saying. It's kind of like that function stuff we're talking about earlier. 2 goes to both 2 square root of 3 and 2 goes to both minus 2 square root of 3.
Mhm.
So those are both solutions. They're both okay. We'll look at that maybe graphically here.
All right.
And then you do the same thing for the other one for -2. So -2 squared. Notice when I substitute in for a negative, I put it in parentheses to avoid sign errors. It ends up being the same setup though. It's y squared equals 12. So y equals plus or minus 2 square root 3. So it ends up being -2, 2 square root of 3, -2 square root of 3.
All right. Very well.
Any idea what the graph of either of these looks like?
Would that be some kind of parabola?
So the first one is a circle, x squared
Oh,
plus y
right.
squared. And you weren't that far off with the second one. So it is called a hyperbola.
Oh, okay. Yeah, I wasn't really sure how to pronounce it.
All right, and then I'm going to zoom out here. So do you see how there could be 4 solution points
Yes.
from the graph? Kind of looks like a tennis ball, maybe a baseball or something.
Yeah.
Baseball. But that's why there are 4 solutions. Graphically, you can see that it hits 4 times like that.
Mm-hmm. Gotcha. All right.
All right.
Sure.
Maybe time for one more. Not sure. Depends what you choose or what you want to do
Mm-hmm.
here. What else kind of looks
Yeah.
appealing here?
Let's see. Okay. 28, I guess.
Okay, so we're convert 60 inches per second to centimeters per minute. All right, do you prefer to go inches to centimeters or seconds to minute first?
Probably inches to centimeter.
Okay, so inches, there is a direct conversion. 1 inch is 2.54 centimeters. That's a known one. That's not me going to Google. That's like a real established one that people use.
Yeah.
So that gets you to the centimeters. Seconds, you're going to put 60 seconds in 1 minute.
Okay. Gotcha. Okay. So that would be 152.4.
That doesn't seem big enough because it's 60 times 2 is 120 times 60 again.
Oh, whoops, sorry. Actually, didn't cross out that. Okay, 9,144.
What did you say with last 9,100?
44.
Okay.
There we go.
So just taking a step back. Why is this new number larger than the original number? Not from the numbers, but from the conversion standpoint.
Mm-hmm.
Like
So
why does it intuitively make sense?
inches going to centimeters. Centimeters are bigger than inches.
Okay. And minutes, there's more, 60 seconds in a full minute. So there's like some
Mhm.
reasonableness to your answer.
Yeah.
Okay.
All right. Very well.
All right. Well, if you don't mind, maybe we could stop here for tonight.
Sounds good. Thank
All
you.
right. Let me stop the recording here.